Okay, so now moving on, this is page 28 for me. You put your page number, and we're talking about real world graphs. So I'm going to switch off of my table of contents, and I am going to move to right here. Okay, this one is a total cutout for you. There were word problems, so I didn't think you wanted to write them. So we're just going to fill in the blanks. All you got to do is write this and then paste it in. Okay, so the first thing they want us to do is describe this real world graph. The graph shows the height of a roller coaster during a single ride. Describe the roller coaster ride. Okay, so the first thing you do is you can see the height is not increasing. So the ride leaves the gate and climbs. So the ride leaves the gate and it climbs because it's climbing right here. Okay. The ride then has a big drop before another smaller climb. So there's the big drop, smaller climb. Then the ride has a smaller drop before doing one last climb and its biggest drop. Then the ride returns to the gate. Okay, so that's what this means. So there's the smaller drop, then it has that extra climb, biggest drop, returning to the gate. Okay, so what they're going to do today is give you a scenario, and they want you to just try to sketch it as best as you can. So in a single day, it snowed lightly during the morning, then heavily for the rest of the day. Graph time on the x-axis and the total snowfall amount on the y-axis. So time is on x, and snowfall is over here. Okay, so it said it snowed lightly during the morning and then heavy for the rest of the day. So the snowfall was really slow to begin with, and then the rest of the day it picked up and moved really fast. So that's how you would represent that. Okay, for number 3, Mia bought a painting. The value of the painting drops 25% after 1 year, then increased in value over the next 5 years, reaching a value that was twice what she paid for it. Graph time on the x-axis and value on the y-axis. Okay, so she bought a painting and it dropped 25%, and then it doubles its value. So you need to start in the middle, and it's going to drop about 25%, and then it doubles its value. So it increases its value where I am doubling the height of that bar. Okay. 4 says a basketball was dropped out of a window on the second floor of a school onto the concrete below. Each time the ball hit the ground, it bounced and reached the height that was half of its previous bounce. It continued doing this until it settled on the ground. Graph time on the x-axis and distance on the y. Okay, so if we're dropping a ball from the top of the second floor, we're starting high. So we drop, it hits the ground, it bounced back up to half its height, and then it fell back to half its height, fell half its height, fell half its height. So each time it's just getting smaller and smaller until it hits the ground. Okay, number 5, Jace is speeding on the highway and gets stopped by a police officer. The officer gives him a ticket and he continues on the highway. Graph time on the x-axis and speed on the y. Okay, so at first he's speeding. So since he is speeding, we already have some momentum going, so we're not starting at 0. So we're going to have a high speed, and he's just going the same constant high speed. But then he gets stopped by a police officer. So you have to show him slowing down until he has no more speed because he's stopped. He's going to be stopped for a little while he's talking with the police officer and gets his ticket. And then he's going to continue going on the highway, and hopefully he's smart enough to not speed again and just do a constant speed that would be the speed limit. Okay, Carlos is running back on his football team. He ran the same number of yards in each of the first 6 games of the season. After the 6th game, he did not play for the rest of the season due to an injury. Graph games on the x-axis and total yards for the season on the y. So this would be yards. Okay, so for the first 6 games, he was constant. A constant rate of change is just increasing at the same rate, so going up at the same speed. Okay, and then after the 6th game, it says that he couldn't play anymore due to an injury. So for the next few games, his yards never increased. He stayed the exact same, so they level off. For number 7, Alice drives a school bus on her morning route. She stops at every block to let students on. Graph time on the x-axis and distance on the y. And then that the bus travels. Okay, so if Alice is driving a school bus, she's going to start from stopping. She's going to be at 0 speed. She's going to increase her speed. She's going to hit a block, and she's going to stop for a little bit so that distance doesn't increase. And then she picks up her speed again because she's going to the next street, and then she has to stop to let the kids on. Then she picks up her speed to go to the next street, and she stops to let the kids on again. And repeat the process until you can't fit it on the graph anymore. So she's just constantly going to increase her distance and then stay the same because she's picking a kid up. Increase her distance, stay the same. So each flat spot is when she picks a kid. Okay, number 8. Ray started his workout by running on the treadmill. His heart rate rapidly increased and remained high during his run. After the treadmill, he lifted weights. His heart rate increased and decreased during this time. Okay, so we want to put time right here, and we want to put heart rate right here. Okay, so you don't start at a 0 heart rate. Otherwise, your heart's not beating and you're not alive. So we're going to start right here, and we're going to show that his heart rate increased rapidly because it said it increased rapidly. And then it remained high during his run. So we're going to leave that it's up high. Okay. And then when he went to lift weights, his heart rate would increase and decrease. So we're going to decrease some and then increase some, and then decrease some and then increase some, and then decrease some and then increase some. Because all you boys that are in football or girls that get to go to the weight room that are in athletics know that while you're doing weights, your heart rate isn't as high as a constant run. Okay, so for those kind of problems, you have to make sure you label your axes and then just try to trace it out as best as you can. For the last example, it says Carrie, Luke, and Mason receive the same allowance each month from their parent. What we want to do is match them to their graph. It says Carrie spent a small amount of her money in the first half of the month, then spent the rest in the second half. Okay, so if she spent a small amount, we want to start increasing slowly. And then if she spent the rest of it, we want to go fast. So the only graph that increases slowly and then jumps fast is this one right here. So this is Carrie. Okay, now I'm going to move to Luke steadily spent his money throughout the entire month. So Luke spent steady the entire time. It was never fast. It was never slow. It was like at the same rate the whole time. So therefore, the only one moving at the same rate would be Luke. And then let's just check to make sure we have it right. It says Mason rapidly spent all of his money at the first of the month, and so he had no more money left to spend. So he spends it all, nothing to spend. So this is Mason. Okay, you have a worksheet to go with this, so if you have any questions, call me over and let me help you.